Okay. On the board is what we need to get done today, ladies and gentlemen. We're going to take our quiz today. We also have to talk about metric conversions and go through a few of those today, ladies and gentlemen. My question to you is this. Would you rather do the quiz first and get it out of the way, or would you rather do it at the end of the hour? I got 2 yeses and 1 no's.
What are we doing if we don't do the quiz first?
Well, we would do the metric conversions first.
What's that?
That's where we convert in the metric system. All right, let's do this. Let's start out with at least our question of the day. Name me 7 ways that you could have $1, but only using one type of money. So in other words, you can't mix and match. So you can't say $5 bills, $1 bills, $10 bills. You can't say things like that. Hang on, I got to get the door. I got to take attendance too, so don't let me forget. Hello, Jasmine. Come on in. Okay, so start thinking about that for a second, ladies and gentlemen. Let me get attendance and a couple other things, and then we'll come back to you for that in just a second. All right. Attendance. There we go. All right. Danielle. Jacqueline. All right, ladies and gentlemen. So give me one of the 7 ways that you can have $1. Okay. Hang on one second, because that looks like $1.60. All right, so we could have 100 pennies. Let me guess, it's frozen. Yeah. Okay. Yeah. That's okay. You didn't want to see my $1.60 anyway. That looks like the same thing you've been showing us, Mr. Brand. What the heck? All right. So give me another way. What? Good. Normally people tell me 10 nickels. I don't know why. Okay. But if you're willing to do 10 nickels for $1, I will give you 10 nickels and you give me $1. Okay. So 20 nickels. 4 quarters.
10 dimes.
Okay, slow down. Thank you, Rocio. 10 dimes. What? $2 half-dollars.
$1 coin.
Okay, 2, 4, 6. Only one left.
$1 bill.
And $1 bill. Okay, so we can all agree that these are all equal to each other, correct? No matter what, how much money do you have? $1. Okay, you have $1. So we could say that 100 pennies equals 4 quarters, correct? They would be the same amount, yes.
It was just
Wow.
at 40%, and
What?
now it's at 20.
Holy cow, at this rate, it should be dead in 2 seconds.
Yeah.
Okay.
My computer died really fast.
Really fast?
Yeah.
See, mine dies slow and painfully. It screams a little and it's like, ah!
It goes.
No, just
Most of our computers died pretty quickly.
You should get
Especially like
And then I
first
get like
50% is fine, and then like
And then after that,
50 to
it's
40
As
is
soon
fine.
as mine
And then
hits
for some
40,
reason
it's
there's like
gone.
a jump from 40 to 10,
yeah, and then it's dead.
and then it's that.
I swear it was at 50 like 30 seconds ago,
That because I pushed my computer, but I did.
but I did.
But I did. Thank you.
It's all a lie.
all right. Okay. So could we also agree then that 2 half dollars equals 20 nickels.
Yeah.
Okay? So, what would happen if we did this?
Be a 1-to-1.
Yeah. I think we need 1 over 1. So just 1.
So, what does that equal?
$1.
No.
$1 over $1.
Which would be equal what in a fraction form? $1 over $1 equals what?
1 over 1.
Which is what?
Which is 1.
1. 1. Anytime we have a fraction where the number on top is equal to the number on the bottom, what does that amount to? 1. It amounts to 1, ladies and gentlemen. Okay? Now, in a few minutes, and actually throughout the rest of this trimester and the next, we're going to use this fact. Okay? There was an old science teacher, his name was Mr. Craig. He would walk into chemistry class and all the time he would go, "Oh, chemistry, multiply by 1 and you're done." And he's right. We multiply by 1 in chemistry all the time. Now, it's a little bit more complicated than that because if you multiply by 1, your number shouldn't change, correct? But what this allows us to do is change from one unit to another and still keep things equal. Okay? So when we were talking about measurements the other day, okay? How many feet in a yard?
3.
3. So if you say 3 feet or 1 yard, you're saying the same amount of distance, correct? So if you put 3 feet over 1 yard, what are you multiplying by?
1.
You're multiplying by 1. Anytime you have two things that are equal to each other, you can multiply by them and get the same answer. Now, it'll change the unit, and it'll change the number, but you're not changing the value of it. And that's the important thing. Whether you say you have 20 nickels, whether you say you have 10 dimes, or whether you say you have a dollar coin, either way, you got $1. $1. The value, the amount that you have doesn't change. The unit that it's in does. The number of coins you would have does. But the value of that number doesn't change. And that's an important thing for chemistry. Okay? And we will get into that in a few minutes. All right? Before we take our quiz today, real quick. Something that does not change in a chemical or something that does not change in an experiment is a what?
Constant.
Is a constant. Something that you compare to in an experiment is a control. 13 red apples. Quantitative or qualitative?
Quantitative.
Nope.
And technically, wait, isn't it both? Because you have the quality.
It's
and the
technically
number.
both. 13 quantitative, red apples, qualitative. So very important fact. You can have quantitative, you can have qualitative, and there are times where you could actually combine both. Okay? Now I've been trying to think of a one where it would be neither. But I really haven't been able to think of one that would be neither. Not quantitative, not qualitative. Okay? So, but you can, if your observation is something where it involves a number and another description, it could actually be both. Okay? It could actually be both. Okay? So, an if-then statement that is a guess of how your experiment is going to turn out. Rocio, what would we call that? An if-then statement. That is a hypothesis. Very good. That is a hypothesis. The variable that I control, Jim, the variable that I as the experimenter have control of, what is that? The one that I control as the experimenter. Which one? I'm sorry? Independent or dependent? Nope. Nope. The one that I control. And the reason I say it this way, I control. is hopefully if you recognize that I control it, it is independent. So that's my little key to help you remember that it's independent. Okay, what changes because you changed the independent variable, Jacqueline? The dependent variable. Haley, what is a variable? Go ahead, say it. Say it. You were good. Say it.
Something that can be changed.
Something that can be changed or something that is changed in an experiment. Okay? Something that could be or that is changed in an experiment. All right. In a direct relationship, Nadia,
Yeah.
the two variables are going in what direction?
In what?
In a direct relationship. A direct relationship relates this variable and this variable. Two different variables. What direction are they going?
In a graph? Or
Okay, in a graph, how are they going?
they're going downward?
Did she point at the wrong thing for you?
No. I mean, that's what I have in my notes from your notes.
That's what you have in your note from my notes, is that in a dependent, wait,
You said
direct, sorry, where did I get dependent? In a direct relationship, I had that the graph is going down.
They're going up or down.
Okay, now hang on, we're confusing two things here. And maybe you copied it wrong, okay? So let's get this straight. In a direct relationship, two variables are changing. So I turn on the water. I leave it on for a certain amount of time, right? What changes because of me leaving the water on?
The amount of water coming out.
The amount of water coming out, correct? So the longer I leave the water on, what happens to the amount of water that comes out? It goes up. So in that case, the time that I leave it on is going up, the amount of water is going up. That is a direct relationship. So on a graph, our line is going to go up. Okay, and if you have it differently, you need to correct that. On a graph, the line is going to go up. What is the other kind of relationship, Cynthia, that is not a direct relationship? What was the opposite of that? An inverse relationship. Now remember, variables can only do two things. What are the only two things a variable can do? Go up or down. Because in science, when we talk about a variable, we're talking about time. We're talking about temperature. We're talking about length or mass or volume or density or things like that. And the only way those things can change because they're measured in their numbers is they either go up or down. Now they could stay the same, right? But then it's a what? Then it's a constant, which means it's not changing, okay? So understand, when you talk about variables, there's only two directions that they can go. They either increase or decrease. If they both go down or they both go up, that is a direct relationship. If one goes up and one goes down, that is an inverse. Inverse was the term we use. I know sometimes they use indirect in other things, but in science we use inverse. And what does that mean for your graph? Your line is going down. What does it mean if you have a straight line on a graph?
Constant.
It is a constant relationship. That means that as the two variables are changing, they're changing at the same rate. So we end up getting what we call a straight line, okay? And again, your straight line can be going up. It's constant, but if it's going up, it's also direct. Your straight line could be going down, meaning it's still constant, but it is now inverse. Inverse and direct are one way of looking at a line. Is it going up or is it going down? Second way of looking at a line is looking at the shape of it. Is it straight? That means constant. What if it's not straight? Well, it could be exponential, but we're going to keep it very simple for you. I don't care about exponential. I don't care about logarithmic. I don't care about any of those right now. We're going to say if the line is curved in any way, that it is simply a non-constant. A non-constant. And you're right. Maybe it is exponential. Maybe it is logarithmic. Maybe it is something else. We don't really care which one it is. We're just going to keep it simple. It's either a straight line or it's a curved line. Okay?
So in a direct relationship, it says that a relationship with as one variable changes up or down, the other variable changes in the same direction. So
Correct.
like they could either be going upwards or downwards.
Well, they're both either going up
or
or they're both either going down.
And then for the inverse, it's either one one's going up, one's going down.
Correct. And we say, with inverse, we only need to say one up, one down, because we don't care which one's going up and which one's going down. They're just going in opposite directions. But in a direct, we could say they're both going up, but somebody else would look at it and say, well, what if they both go down? Well, it's still direct, because they're still moving in the same direction. Okay? Questions?
Yes. Just kidding.
You sure? You don't have any other questions? Okay. How about a yellow school bus? Qualitative. Qualitative. Okay? Because it's describing the color. Okay? A horrible odor. Qualitative. 16 feet. Quantitative. Numbers got to be quantitative. No numbers got to be qualitative. All right. Questions? All right, let's take our quiz. Let's get that out of the way, ladies and gentlemen. Okay? So, here's what I need you to do. If your desk is next to somebody, put a little bit of space in between it, please. Okay? Put a little bit of space in between it, please. Okay? Normally, I would spread the desks out on test day and things, but the best I can do is have you spread out a little bit. Okay? All right. So, in Google Classroom, ladies and gentlemen, I'm posting the quiz right now. So, it's going to be the top thing in Google Classroom, ladies and gentlemen. There are 17 points on it, ladies and gentlemen. Now, again, before I post it, a couple of things real quick. Hopefully, this will be a fairly easy quiz for you. But on a quiz, important things. Number one, if you read something and you don't understand it, raise your hand and call me over. Now, I will not give you answers, but I will explain it as best as I can. Okay? Number two, on a quiz, you cannot call me over and go, is that right? Because if I say no, what are you going to do? You're going to change it. So I cannot tell you if an answer is right or wrong on a quiz until after you're done with it and you turn it in. Okay? The other thing is right now on your desk, put everything under your desk except for your 2 pink sheets, please. Okay? If you don't have anything on them and you don't want to take them out, you do not have to. Okay? But those are the 2 things that you can have out on your desk now. All right? So can you throw your book underneath, please? I know it's, what book is it? Edge of the what?
That's AP World.
Oh, I thought you
Edge
said
of the
Edge
World.
of the World.
Edge of the World textbook.
I'm like, what are you, a flat earther or what? So,
This is the whole textbook proving one.
again, any last questions before we, yes, go ahead.
Your charger's not charging.
My charger doesn't have to charge, it's already charged.
Oh, but I'm not charging my computer.
Try a
Go on the
different
other side.
side. Try a different port.
Try the other side.
The other
Like-
side,
like
you're
this
probably
side.
only gonna,
Right here.
Oh.
yeah, it's gotta be the right kind of port.
I mean,
Yeah,
the
sometimes
dots
it's
Shouldn't
are-
one
both
side.
sides work?
The dots are-
It should, but again, sometimes weird things happen because my chargers, what's that?
It's working.
See, you're yelling at me about my charger. It's your computer, not my fault. Okay? All right? So again, while you're taking a quiz, if you ever have a question, raise your hand, call me over. I'll be happy to come over, try to explain things as best as we can, or as best I can. Or I will at least put it in some context. You remember we were talking about this or that, or in the lab, the control would have been the room temperature water or something like that. So I can help you out some with that if you need it. All right? Nadia, slide your butt over a little bit. Thank you. All right. All right. I'm going to post the quiz, ladies and gentlemen. When you're done, just hang out until everybody is finished. By the way, when you get the quiz back and you look at your score, please understand that it is not going to be as high as it should be. The reason for that is I have to grade the free response questions. It's going to put them in as a score of 0. So I think there's like 8 points on the quiz that are free response questions. So don't panic if you get a 9 out of 17 right away. It means you got all the multiple choice right, and I have to grade the other ones, just so you know. Okay? Questions? All right. Assigning it, ladies and gentlemen. There it is. Go into Google Classroom, click on it, ladies and gentlemen, and go ahead and get to work on it. If you have questions, again, please feel free to raise your hand. Let me know. I will come over and I will give you some assistance. But it should be there. You might have to refresh your screen. But there's the vocabulary quiz for today. This is not, ladies and gentlemen, going to take us all hour, so go to work on it, get done, and then chill out for a few minutes. Give me an example of a measurement, please. A whole measurement, not just a unit. Make up an example of an entire measurement. Go ahead.
1 meter.
1 meter.
It's not up there.
Wait, what?
Oh my gosh. Sorry. There we go. Give me an example of a measurement. Doesn't even have to be in the metric system. Just give me an example of a measurement.
5 feet.
5 feet.
9 seconds.
9 seconds.
8 minutes.
12 kilometers. 8 minutes. Apparently you people don't like decimals.
72.8 ounces.
I like that. We finally used a decimal and then we went back to the non-metric system, but that's okay because I said it didn't have to be. Okay, so when, yes, 9.3 centimeters. Okay, so when we look at these, ladies and gentlemen, all of these measurements show 3 things. Every single one of them. What's one thing that they all show? Okay, they all have a quantity or a number. A quantity or a number. What? They all have a unit. Now, in science, okay, in science, there are only a couple of times where you will not put units on numbers. There are only a few times, very few. And I can't think of any that we will do in chemistry. So please understand that in chemistry especially, anytime you have a number, you should have a unit with it. Might be grams, might be milliliters, might be, could be cubic centimeters, could be liters, could be atmospheres, could be PSI, any of those. But you will almost always in chemistry have a unit. Even when we start talking about errors, we will talk about something called percent error, which would mean that percent would be your unit in reality. Okay? Okay, now those two are the easy ones. Every measurement in science also shows a third thing. Does anyone know what that is? And it's not as easy. The number and unit, yes, we clearly see. The third thing is a little bit more difficult to find.
Uncertainty.
What? Go ahead. What?
Uncertainty.
Absolutely correct. Uncertainty slash precision. We put those two together, ladies and gentlemen. Okay? We put those two together. So any measurement in science shows a quantity, any measurement in science shows a unit, and any measurement in science shows uncertainty slash precision. So you remember the other day when I told you, if your number ends with 0.00 or 0.30, don't drop the 0. That last one is why. That's called precision. Precision says my instrument reads to this place. So I have to report my answer to this place. I don't just drop zeros because they have no meaning. Okay? In science, 9.3 and 9.30 are not the same thing. They are the same value. I will not argue that with you. But 9.3 centimeters and 9.30 centimeters tell you something a little bit different about your measurement. So we don't ever drop zeros. Okay? We don't ever drop zeros. And especially on a digital instrument. Okay? For science, for this class, we bought balances that go all the way to the milligram, to the 0.001 gram. Okay? Now again, those are expensive balances. Those are about $1,200. If I only wanted to go to the 10th of a gram, I could buy balances for about $200 that do that. Okay? So the reason that we have those is so that we can make a very precise measurement in this class. So please don't take that precision away by just dropping zeros. And we will get into explaining the rules and things like this about it. But these are the three things that every measurement shows, and you might need that for your assignment that you're about to turn in on the scientific measurement lab. Questions? All right. So then, ladies and gentlemen, I think the only thing that we have left to do here is write a conclusion. Now, the conclusion should go back and always match your purpose, okay? So our purpose, ladies and gentlemen, if you remember, was to relate unit, instrument, and type of measurement by looking at different instruments. And then determine the type of measurement and the place an instrument reads to. So this is really what our lab was about. When you were looking at that instrument, you were trying to determine what kind of measurement it makes, okay? Trying to determine what kind of measurement it makes. And also we were looking at what place that it reads to. When you get to the lab and you are looking at an instrument, all instruments read in different places, ladies and gentlemen. Just because something is a graduated cylinder doesn't mean it's going to read the same as the graduated cylinder that may be right next to it. So when you do this, ladies and gentlemen, you need to figure out what place an instrument reads to. We will practice this a lot more in a little while, ladies and gentlemen. Okay? But I wanted to introduce you to the idea. So those are the things that we are going to write our conclusion on. How did we determine what type of measurement an instrument makes? And how did we determine what place an instrument reads to? Now, the only way to determine what place an instrument reads to is to look at the what on it? The markings. To look at the markings and the numbers by them. Because the markings and the numbers by them will tell you, okay, does this read to tens? Does it read to hundreds? Does it read to ones? Does it go to the tenths? Okay? And that's what you have to look at. And by the way, whenever you are determining what place an instrument reads to, my suggestion is to look at the numbers that are clearly written on it. So for example, when you look at it and it's marked out 10, 20, 30, 40, 50, 60. Okay, we know it's reading in the tens place. Now ask yourself, does it go any smaller than that? Smaller than the tens place would be to the ones. So now you look between 10 and 20 and you ask yourself, is there 11, 12, 13, 14, all the way to 19? If there is, it's reading to the ones place. If not, it's reading to the tens. And every mark has to be there. You can't, bless you, you cannot have every other mark. You cannot be every 2, 4, 6, 8. Every mark has to be there to be more precise. Okay? Sometimes things will be marked out in 5, 10, 15, 20. The 5 may help you estimate. Is it above 15 or below 15? But it doesn't have precision. Okay? That instrument would read to the tens place. So, okay, you look at it, you see the tens marked out. Then you see ones places. Now you look and you say, okay, is there anything between 11 and 12? Any marks there? Maybe it reads to the tens. Okay? So that is what you should have been doing in the lab yesterday. Now again, please remember, I am not going to grade you in this top area on the names of the instrument. I do expect you to give me the unit and be correct. I do expect you to tell me what place it reads to. And more important, I expect you to tell me the type of measurement. because if you know the unit, you should know the type of measurement. Okay? Even if you have to look it up in Google or somewhere. All right? All right. So for your conclusion, ladies and gentlemen, your conclusion needs to include a couple of things. Number one, you need to tell me how you figured out what the instrument read to. So in this lab, I learned what type of measurement the instrument took by looking for what. What did you look for? Okay? And you need to use some data to support your findings. Now, what does data mean?
Numbers.
Somewhere in here, you got to have some numbers. Now, I don't care if you type out the numbers or if you type out the words for the numbers, but somewhere in here, you have to have some numbers. So if you don't, it's real easy. You're losing 1 point on your conclusion. Okay? You're losing 1 point on your conclusion. So when we talked about what place it reads to, you can talk in your conclusion about how it was marked out by 10, then 20, then 30. Therefore, it's reading to the tens place. Or it was marked out at 6, 7, and 8. So therefore, it was reading to the ones place. But that's what you have to have in your conclusion. Okay? That is what you have to have in your conclusion. Take a couple minutes right now. Write up your conclusion. That should be the last thing that you need to do. And then if you would, you could turn it in for me, please. I will not mark it late. It was supposed to be due tomorrow. It's my fault we didn't get to these things that we should have gotten to. So again, I'm not going to mark it late if you turn it in today. But if you don't turn it in today, yes, I am going to mark it late. Isha, can you go to your left just a little bit, please? Thank you. I had you guys separate, now I'm putting you back together. Sorry. Okay. This is our first instrument, ladies and gentlemen. This weird looking thing. Anyone know what this is called?
No.
Boiling flask.
It's not a boiling flask. It's not a beaker. This is called a volumetric flask. Now, you guys pointed something out to me on here that I had not noticed before. But it does have a temperature on here. The reason it has a temperature on here is this, ladies and gentlemen. The density of liquids changes depending on their temperature. Meaning, the volume of a liquid when it is cold is smaller. The volume of a liquid when it is hot is larger. The purpose of this instrument is to measure out 100 milliliters of something. That is the entire purpose of this instrument. And I have flasks like this in back for 500, for 1,000, and for 2,000. And what they're really for is for mixing up a certain amount of chemicals. So if you need 100 milliliters of a chemical, you do it in here because you're going to get a very accurate measurement. Because there's only one line on here. The only thing this measures is 100 milliliters. Okay? So this is called a volumetric flask. I did not expect you to know that, but that is what this is called. You guys will probably never use these in class because the chemicals should already be mixed up and done for you. Okay? But again, There's only one mark on here. One mark for 100 milliliters. That's it. All right. Instrument number 2, ladies and gentlemen, was our thermometer. Okay? So you should have looked at it. And by the way, this one only reads in Celsius because it's for a science classroom. Okay? Normally, a lot of thermometers will read in Celsius and in Fahrenheit. This, ladies and gentlemen, some of you looked on the back. What was this? Was a hanging scale. Was a hanging scale. Okay? It was a hanging scale. Okay? What instrument did it do the same purpose as from your lab activity? The balance, yes. The balance, okay? Now, technically, this is a scale because it's reading in ounces, but it also could be called a balance because it's also reading in grams, okay? All right. This was the weird one, ladies and gentlemen. This was station number 4. Now, if you looked at it, you saw that it was called a what? Multimeter. And what it is for measuring all kinds of electrical things, okay? But what does ACV stand for? Because right now it's set at 200 ACV. Did anybody find what AC? By the way, it's AC and V. Anybody know what AC stands for? Alternating current. That is what comes out of the outlets in the room. That is what powers the lights in the room. When you plug things into an outlet, they work on alternating current here in the United States. If you were in Europe, they work on direct current. Different system, okay? But also, can you put a plug into an outlet either way?
Well, it depends on the outlet.
It depends on the outlet, and some of the newer plugs have one wider end than the other. But years ago, the old plugs, you could plug them in either way, upside down or right side up.
Some are 3 prongs.
Some are 3 prongs now, too. Can you put a battery in your device the wrong direction? No. Batteries are what are called direct current. They have a positive and a negative end. There's only one way they can go in. This is measuring alternating current. And what does V stand for? Volts. Volts is how much difference there is between the two ends of something. It's what's called the potential difference. Okay? All right. Station number 5 in the back was this. Again, just showing it for the video. This is a what?
Beaker.
A beaker. Okay? A beaker. Now, here's the other thing. There are people who look at this and go, well, Mr. Brand, does this really read to the tens place? Because it starts at 20 and goes up to 80. There is no mark for 10. It's still technically marked out in the tens place. By the way, why on one side do the numbers go up and on the other side they go down? Don't be sorry. Put her away. What?
If you're pouring something?
Thank you. One side is for if you're filling it to see how much is in it. The other side is if you're pouring stuff out, you can measure how much you poured out. Just so you know. Okay? All right. Next one, ladies and gentlemen, was this one. The big sucky thingy. Okay? Anyone know what this is actually called?
Serological.
A what? A pipette. Serological, yes. Here's what it does, ladies and gentlemen. When you turn this wheel and put this in a liquid, you will pick up a certain amount of liquid. You will hold it in there until you press this button at the top, and then you will dispense it into a container. Okay? Now, if you're a fan of the TV shows that have the crime dramas, like the CSI, the NCIS, those where they work in a lab, there are ones of these that you can literally dip into a thing. You press a button on the top, and it will pull up 0.01 of a milliliter. Then you take it over, you press the button, and it'll put it into another container. So this is for transferring liquids and measuring them very precisely because this instrument only measures 10 milliliters, and it's marked out in the tens. Okay? There are ones of these that'll do 25, 50, 100 milliliters, But again, they only hold so much, and that's what they're there for. Okay. This part up here is called the pipette bulb. Okay. It's what causes it to suck it up. So the sucky thingy was a very accurate description of it. Okay. All right. And that was this thing here, in case you're ever watching the video and going, what the heck was it? Okay. That was that station there. Obviously, the next station that I'm not going to bring up here was the balance. Okay. Then station 8, we had a ruler. Good. By the way, this ruler is marked out in centimeters and millimeters. So the rulers I have in the class, even the larger ones, the meter sticks, are only marked out in the metric system. So you will never measure anything in here in inches or feet. Okay? We could convert to inches or feet, but this is marked out in centimeters and millimeters for you. Okay, what was this last thing, ladies and gentlemen?
Pressure gauge.
A pressure gauge. Okay? It's been disconnected from the tank that it was on, but it is a pressure gauge, ladies and gentlemen. And if you want to see the pressure of a gas inside a container, it will have one of these on it. Now, this has a lot of different scales on it, actually, ladies and gentlemen. Okay? It's measuring in kPa, it's measuring in PSI, and it's measuring in inches of mercury vacuum. Okay? Yeah, exactly. Inches of mercury vacuum. Okay? In science, measurements are never what kind of number? Negative. Negative. You cannot have a negative mass. You can't be like minus 5 grams of something. You cannot have a negative pressure. Well, technically you can. You can have what is called a vacuum. Okay? We won't ever deal with that though. So pressures have to be positive numbers. You can never have a gas occupy a negative amount of space. Its volume can never be negative. Okay? You can have a negative what though? What is the one measurement in science that can be negative? Temperature. It is possible to be below 0 on the Celsius scale and on the Fahrenheit scale, correct? But you can't be negative in what scale? Kelvin. And that's why we have the Kelvin scale in science. Because just like any other measurement, there are times where a number cannot be negative. Okay? And we'll learn that in gas laws. Okay? Questions, ladies and gentlemen? All right, there was that last one. Okay, good. All right, so please make sure you turn that in. You should be done with that, ladies and gentlemen. It should be finished. It should be complete. In your EISN, ladies and gentlemen, I am on this slide, and I think in yours it is slide number 24. Nope, it's slide number, well, let's start with slide number 22. Sorry. Wow. In yours, slide number 18. Sorry. 18. Start there, ladies and gentlemen. We'll get to that other part in a minute. Okay. Yesterday, we told you that there were 7 base units. They're up there. Meter, kilogram, second, Kelvin, and mole will be the ones that we use. We will not use ampere. We will not use candela. Okay? But there's a lot more things than that we measure, right? Matter of fact, what did this, and that measure? Volume. How come volume's not up there? How come volume is not a base unit?
Can you find it from one of those or 2 of those?
Which one can we find it from?
Mass.
Nope.
Length.
Yeah, there's the one. If you wanted to find the volume of this desk, what would you use? We would use length times width times height, which is length 3 times. Therefore, it's made up by a base unit, right? But there are 2 kinds of units in the world. There is what is called the base unit, those 7, and there is what is called the derived unit, not those 7, okay? A base unit, ladies and gentlemen, come on. Turn it on. That'll work better. Base unit is one of the 7 defined units up there. Now, I want to point one thing out. if we put something in front of meter, kilometer, centimeter, millimeter, it doesn't change the fact that it's still one of the 7 base units. It changes how big that unit is, correct? Okay? Now, the only one up there that actually has a prefix in front of it is kilograms. So technically, if they ask you what the base unit for length is, you should say meter. But understand, if we put a kilometer in front of it, it doesn't change the fact that it's still one of the 7 base units. It just has a prefix with it. Okay? So they're defined as one of the 7 units. They only measure one thing. That's all they measure. One thing. Okay? One thing. And they are taken with an instrument. We showed you a bunch of instruments that you can use. Examples. Meter, second, Kelvin, kilogram. We could do the other 2, but the other 3, but I'm going to stop there. By the way, kilogram is the only base unit that has a prefix already in it right away. The only one. Okay? Now, does that mean you could not talk about a kilokelvin? You could. I have never, ever in my life heard somebody talk about a kilokelvin. 1,000 Kelvin.
Sounds like a really high temperature.
What's that?
Sounds like a really high temperature.
Yeah. But think about it. That pipe on the wall is what state of matter? Solid. If you want to melt that pipe, it will melt. You got to get it up to about 2,800 degrees Celsius. So I guess you could say 2.8 kilo Celsius degrees. That sounds terrible, doesn't it?
Yeah.
Yeah, let's not use that. Okay? Let's not use that. Okay? But the point is, those prefixes could be used. And actually, in time, we do use them. Not for larger units, but for smaller. We'll talk about milliseconds or nanoseconds or things like that. Okay? A derived units, there are millions of different derived units. Okay? There are millions of different derived units. They are created by multiplication or division of base units. Now, here's the other thing to understand. If you are adding units together, what must be true about the units? They have to be the same unit measuring the same thing. You cannot add a kilogram and a gram together. Okay? You would have to either convert them both into grams or both into kilograms and then add them together. Multiplication, you can have different units. Okay? Multiplication and division, you can have different units. And you end up with something like kilogram times meters over seconds squared. Multiplying mass, distance, and dividing by time squared. That is a derived unit. Grams per cubic centimeter. Cubic centimeter is actually a derived unit, made up by length times width times height, the volume of something. When we divide this is a very common measurement in science. Anybody know what measurement ends up in grams per cubic centimeter? Mass over volume. Starts with D, ends with density.
Density?
Good, density. You guys are good at this game. Good, 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 good. By the way, this one is the same. Whether it's grams per cubic centimeter or grams per milliliter, it measures density. Okay? So they are taken with an instrument, the same as base units. Okay? Possibly multiple instruments. What I mean by that is if we're going to take the mass, we need a what? Balance. If we're going to do volume, we either need a beaker, graduated cylinder, maybe a ruler, something like that. Okay? They may sound like a base unit. What I mean by that is if we look up there, kilogram, second, ampere, right? One word. Well, here, you could see 3 different units, correct? Here, you could see 2 different units. What if I told you a Newton? Does that sound like one thing or does it sound like multiple units? Sounds like one. Guess what? That one at the top, that's a Newton. Okay? Rather than people saying kilograms times meters over seconds squared all the time, we call this whole unit a Newton. Okay? We call it a Newton. Okay? Joule is a unit for measuring energy. Okay? That doesn't make it a base unit. Even though it may sound like a single unit, that does not make it a base unit. It is actually made up of other units. And sometimes we do that. The measurement is common enough that we give it a separate name. But it's got to be up there to be a base unit, ladies and gentlemen. If it's not up there, it's not a base unit. Okay? Not up there, it's not a base unit. Okay? Common derived units may be given a single name such as joule. Questions? All right, good. Whoop. If they are not one of the 7 base units, they're a derived unit. Those are your only 2 options too. Okay? Kind of like qualitative and quantitative. Either it has numbers and it's quantitative, or it has no numbers and it's qualitative. It's either a derived or a base unit. Those are your only 2 choices. Questions? Wonderful. Okay. Yeah, that worked out well for me. Okay. See, I was supposed to have all these things down here at the bottom. And then we were supposed to pick one and decide if it was a base or a derived unit. But obviously, I suck at this game and didn't have that quite ready. Well, what? Well, I guess we're not doing that. Okay? But please remember, millisecond is a base unit. Why?
Because it's a second.
It's a second with a prefix in front of it. Okay? Second with a prefix in front of it. Hertz. Not a base unit. I know. That one hurt me. Hurt me too. Okay? Anybody remember the rental car company Hertz? No? Okay, good. By the way, Hertz is what you tune your radio with. The frequency of the radio station, 101.1, that's kilohertz. You can get into megahertz and things like that as well too. Liter times kPa divided by mole times Kelvin. This is a unit for gas laws. Pascal is a unit of pressure. Molarity is a unit that describes how strong a solution is. And calorie is describing energy, ladies and gentlemen. Calorie is describing energy. Hey, we got 6 minutes yet. Where are you going? Well, good. Leave your computer open. You never know when you're going to need it. Okay. So this, ladies and gentlemen, are metric prefixes. We are going to have to be able to convert with metric prefixes. Now, here's the honest to goodness truth. Just like places on a number line, there is a place for every digit on a number, correct? Okay. Well, there is a prefix for every one of those places as well. Okay? So here's our central unit. You'll notice I didn't call it the what unit? Base. Why?
Because it cannot be a base. It can not be a base unit.
Which one is not a base unit?
Liter.
Liter. Liter is not a base unit. However, gram and meter are, but these are the 3 most common measurements we're going to make in this class. Measuring distance, measuring mass, measuring volume. Okay? And also I have some of them highlighted here in an orangish color. Why?
Those are the most common of the most common.
Those are the most common. I have never, it exists, but I have never asked someone to tell me how many hectoliters something is. It exists, but we don't put hecto in front of liter ever. Ever. We can, but we don't. Okay? So these ones here, and by the way, I probably should have highlighted this one as well because kilogram is a common enough one that it will be measured. But for us in chemistry, we measure everything in grams. Okay? We measure everything in grams because we work with smaller amounts. I have never heard of anybody talk about a decameter, a decaliter, a decagram. You could, but again, you don't. But, by the way, I've seen it spelled either way. And I didn't make up this system because if I did, I wouldn't have used deca here and deci here where the only difference between them is one stinking letter. Okay? But somebody did. But what do you notice about these? They get what? Smaller and bigger. Right? By how much? Times 10. That is the entire metric system. Now, here's the nice part about the metric system. Because everything gets 10, 100, or 1,000 times bigger, all you are going to be asked to do in reality is slide a decimal point. Slide a decimal point. Okay? But again, you need to know, ladies and gentlemen, which is the bigger and which one is the smaller unit. Okay? Now, we will use centimeters in here. We will use millimeters. We will use occasionally milligrams because that's what our balances read to. And we will use milliliters. Okay? But you've got to be able to convert between these, ladies and gentlemen. These are the facts that allow us to convert. These are like saying 4 quarters equals $1. These two mean the exact same amount. 1,000 meters and 1 kilometer mean the exact same distance. 100 centimeters and 1 meter means the exact same distance. This meter stick is 1 meter long. 1 meter. But it is marked out in 100 centimeters. Okay? 100 centimeters. Okay? If we were to have 1,000 marks on here, it would be marked out in millimeters. Okay? It would be marked out in millimeters because milli means 1,000 of something. Now, I am not expecting you to memorize these. I will give them to you. You will learn them. Okay? And even I started in Unit 5 with my second half of this class. I gave them the one that they are going to need in that unit, which is 1,000 milliliters equals 1 liter, and I had them write it on their periodic table. So again, I'm not expecting you to memorize these, but I'm going to show you how to use them, and I expect you to know how to use them. Okay? And I'm just going to show you this problem today, and then that'll be it. So if we are going to convert from one unit to another, from 0.985 liters to milliliters, we need to use the relationship down here between liters and milliliters. So here's liters, ladies and gentlemen. Here's milli. This is the relationship we are going to use. 1,000 milliliters equals 1 liter. So that is what we are going to use to convert from liters to milliliters. We then take and, oops. Okay, we'll stop there. We'll stop there. It makes more sense to stop there. It is a matter of either dividing by 1,000 or multiplying by it, depending on which way you're going. Yes. Sounds easy, but you would be amazed how many students get that wrong. All right. Ladies and gentlemen, we are at the end of week 1. Next week, when I see you having your phone on your desk or your headphones in your ears, you'll be putting them in here. Yes? The lab safety quiz we did too. It's online. You can do it. And if you don't get 100, you can go back and you can correct your answers. Nope. Nope. Not for here. Not for here. I trust you. Go away, ladies and gentlemen. Have a great weekend. We'll see you on Monday. Goodbye, goodbye, goodbye. I will have it done by the end of the day. I'm sorry. I have 4th hour off. I'm going to write myself a note right now to do it. I should have done it before, but I will get it in there for you. You bet.
Thank you.
See you. Have a good weekend.
Shania Gray, Radium of Maui, Everina Angelea, Jocelyn Arago, Jandora, Kiriana Campbell.
Hello, sir.
I have to drop 5th hour because I have to go to work.
What?
I have to drop 5th hour because I have to go to work. That's it.
Colster, Mason Upsell Van Roy, Deanna Johnson, Lucy Magnuson, Deanna Maldonado Rayzone, Emily McGuire, Matuda Masafri.
There you go, sir.
Thank you.
Can I come today, though?
Well, you should, because until they get that change, you'd be marked absent.
Okay, so I can take the test, right?
The quiz, yeah.
Okay.
Yeah. Take it for fun. What the heck?
Yeah.
See how well you do. Hello, Kiana. How are you?
Okay, I guess.
I just okay. What's the matter?
It's cold.
No. 68 degrees in here.
and I woke up and then I fell back asleep and I was almost late.
Wow. You woke up, you fell back asleep, and were almost late.
Yeah, because
That's not a good
I
thing.
got ready and then I fell back asleep.
Oh, I hate it when that happens. That's why I don't sit down once I get ready.
But then I didn't understand. Like.
Hey, blood.
Vinny!
Hi. That's barely hitting us for a second. This far away.
So it was that far away, but it was barely hitting. Explain that to me.
Yeah, barely hitting it, almost hitting it.
So it hit it, or it
Oh no,
didn't?
barely hitting it. So almost hitting it. Almost hitting it.
Okay. Because barely means it hit it.
Yeah, you're right.
Almost means it didn't.
Do you have a charger block? Just to
I
charge
do. I do.
it? Can I like charge my phone up for a bit until it talks to you?
What?
What? My computer's almost dead.
Why?
Because somebody forgot to charge it.
What are you doing? Why did you somebody you plan on me? I don't know where I don't know where you're from.
Thank you.
You're welcome. See, Kaylee's not complaining about it being cold because she brought a sweater, but she's gonna go throw her jacket in her locker. What? Not if you make it back on time, but the more longer you sit here and talk to me, the less chance there is of that happening. Dang kids. Dang kids.
No
We
reaction.
have those drinks on my job.
It's crazy, I have no one.
Really? Drinks like how do they taste? Because they look really disgusting.
The green apple's the best one in my opinion. But they only have the green
Let's have Bob Ross drinks. They're great.
That's great.
That's what it's. Please don't hurt.
This one kind of tastes like pineapple.
Chi grape.
She's worried about being late. Now she's out in the hall talking to somebody, making them late to class.
It's not nice. Yeah, I always in the crowd.
No, you weren't. You were standing out there in the hall.
Then I went in.
If it wasn't,
No.
that'd be it.
It's